Welcome to Tech Talk. I'm your host, Diya, and we're on a mission to unravel the complexities of modern tech today. We're shining our spotlight on something that's been lurking in the shadows of microservices architecture. The hidden tax of the TCP three-way handshake. Joining me is Mitesh, an expert in performance optimization and latency reduction. Welcome, Mitesh. Your expertise will help us understand the intricacies of this often overlooked issue. Mitesh, let's dive right in. What exactly is the hidden tax we're talking about here?
Well, Diya, it's a pleasure to be on your show today. Let me paint you a picture. You know how microservices communicate over networks? Yes. They use something called TCP, Transmission Control Protocol, for reliable data transfer. Now, when two services want to chat, they have to go through this little dance called the three-way handshake. First, the client says, "Hello. I'm here, let's talk." That's the SYN packet. Then the server responds with, "Hi there. I'm ready too, and here's my secret number." That's the SYNACK packet. Finally, the client says, "Great. Here's mine." That's the ACK packet. Now, this handshake is fantastic for ensuring both parties are ready and willing to talk. But here's where it gets interesting. Every time a new connection is made, and microservices can make a lot of connections, there's a cost involved: latency. This hidden tax, Diya, is the extra time it takes to complete this handshake before data can actually flow between services. It might seem small, but in a high-traffic, low-latency environment like microservices architecture, even a few milliseconds can add up, and that's what we're here to discuss.
Wow, that sounds like a fascinating topic, Mitesh. I'm intrigued by the idea of this hidden tax. The concept of latency, adding up over millions of connections, is mind-boggling. Mitesh, let me ask you, how do you quantify the impact of this hidden tax on real-world applications? What kind of numbers or metrics can we look at to understand its true cost?
Oh boy, Diya. That's a great question. Let me put it into perspective for you. So imagine a typical microservices architecture, like one powering an e-commerce platform, perhaps. Now think about all those connections being made constantly. User requests coming in, services talking to each other. It's like a bustling city with millions of cars driving around. If each connection takes, say, 10 milliseconds ms for the handshake, which is quite conservative, by the way, that might not seem like much. But let's do some math here. Suppose your platform has 0 requests per second. That's 36 million requests an hour. If each request adds just 10 ms of latency due to the handshake, that's, wait for it, almost 5 hours of collective delay every single hour. Gasp. I know, right? It's like having a massive traffic jam in our city analogy, cars sitting idle while they wait for the green light. That's the power of compounding latency. And remember, we're talking about just one component here, the three-way handshake. But here's where it gets interesting. We can quantify this impact using various metrics. 1. Response time. This is how long it takes for a service to respond to a request. The hidden tax increases response times, leading to poor user experience and potentially lost business. 2. Throughput. That's the rate at which requests are handled by your services. More latency means lower throughput, like having fewer cars on the road due to that pesky traffic jam. 3. Error rates. Higher latency can increase error rates too. Services might time out waiting for responses, or users might abandon requests before they complete. So, Diya, While it's hard to put an exact dollar figure on this hidden tax, we can certainly feel its impact through these metrics. And trust me, the costs can add up quicker than you'd think.
Whoa! Mitesh, that's a staggering example. I'm starting to see why this hidden tax is such a big deal. I love how you broke it down using those key metrics: response time, throughput, and error rates. Mitesh, let me ask you, what are some strategies or optimizations that can help mitigate this latency issue? Are there any specific techniques or technologies that can help reduce the impact of the three-way handshake?
Oh boy, Diya, you're really getting to the heart of it now. There are indeed several strategies we can employ to tackle this hidden tax and keep our microservices architecture humming along like a well-oiled machine. First off, let's talk about connection pooling. It's like having a taxi queue at the airport. Instead of hailing a new cab each time you need one, you have a pool of available cabs ready to go. In this context, we maintain a pool of open connections with our services, so when a request comes in, we can just grab an existing connection from the pool and skip the handshake altogether. Now you might be thinking, that sounds great, Mitesh. But what if all my taxis, I mean connections, are out on jobs? What then? Well, that brings us to our next strategy: connection reuse. With connection reuse, once a request is complete, instead of closing the connection, we keep it open for a short while. This way, if another request comes in soon after, we can use the same connection without having to go through the handshake again, kind of like that taxi dropping you off and waiting nearby for your next trip. But wait, there's more. We can also leverage something called keep alive to extend the lifespan of our connections. With keep alive, we periodically send a small packet over the connection just to say, hey, I'm still here. This helps prevent connections from timing out and being closed prematurely. And finally, drum roll please. Let's not forget about proxies. They can act as intermediaries between clients and services, handling many of those pesky handshakes themselves. By using a proxy, we can offload some of that latency onto the proxy server instead, leaving our precious microservices to do what they do best: serving requests quickly and efficiently. So there you have it, Diya. Connection pooling, reuse, keep alive, and proxies. These are just a few techniques we can use to keep that hidden tax from breaking the bank, or should I say, slowing down our services.
Woohoo! Mitesh, you're on fire today. I love how you broke it down into actionable strategies that listeners can implement right away. Connection pooling, reuse, keep alive, and proxies. That's a powerful combo. Mitesh, let me ask you, how do we know which of these strategies is the best fit for our specific use case? Or should we say, how do we decide on the right cocktail of these techniques to optimize performance and minimize that hidden tax?
Oh boy, Diya. That's an excellent question. It's like trying to figure out the perfect pizza toppings. Sometimes you gotta experiment a bit to get it just right, you know. First things first, we need to understand our applications, workload, and traffic patterns. Are requests coming in steady and slow, or are they bursty and fast-paced? Knowing this can help us decide which strategies to prioritize. For example, if your app deals with a lot of sudden traffic spikes, like what happens when you're the latest viral sensation on social media, connection pooling might be your secret weapon. It helps ensure there are always open connections ready to serve those peak loads without breaking a sweat. On the other hand, if your requests are more spread out and consistent, connection reuse could be the real hero. By reusing connections for multiple requests in succession, you can keep that handshake latency at bay, like when you're on a roll with orders at your favorite drive-thru. But remember, Diya, it's not always one size fits all. Sometimes, we need to mix and match these strategies to get the best results. That's where profiling and monitoring come in. We gotta keep an eye on our app's performance and make data-driven decisions. So how do you decide which cocktail of techniques is just right? Here's a simple step-by-step guide. 1. Profile your workload. Understand the traffic patterns and request rates of your services. 2. Start with the basics. Begin by implementing connection pooling and reuse. They're easy to set up and have broad appeal. 3. Monitor performance. Keep an eye on key metrics like response time, throughput, and error rates to see how things are shaping up. 4. Iterate and refine. Based on your observations, add or tweak other strategies like keep alive or proxies until you find that sweet spot. 5. Keep learning. Tech is always evolving, so stay curious and keep an ear out for new techniques and best practices. And there you have it, Diya. It's all about understanding your app's unique needs and experimenting with different strategies to minimize that pesky hidden tax.
Wow. Mitesh, I'm blown away by the depth of knowledge and expertise you're sharing today. That step-by-step guide is incredibly actionable and will undoubtedly help listeners improve their microservices architecture. Mitesh, before we wrap up, I have to ask, what's next for optimizing microservices performance? Are there emerging technologies or trends that you think will revolutionize the way we design and deploy these systems?
Oh boy, Diya. It's been an absolute pleasure chatting with you about this fascinating topic. And you know what? I'm thrilled to see where the world of microservices is heading. It's like looking at a vast ocean full of exciting new horizons. One trend that's really got my eyes sparkling is service mesh. You might have heard of projects like Istio or Linkerd. They're like a magical net cast over our microservices, providing a whole host of performance-boosting features out of the box. Things like automatic service discovery, load balancing, and even advanced traffic management capabilities. It's like having your very own personal assistant for each service. Another exciting development is gRPC. That stands for Google Remote Procedure Call, but don't let the name fool you. It's not just for Googlers. gRPC allows our services to communicate using HTTP2 and a clever binary protocol, which can lead to some serious speed improvements. Plus, it supports features like streaming requests and responses. Talk about taking inter-service communication to the next level. And let's not forget about WebAssembly, or WASM for short. While it's still in its early stages, WASM has the potential to revolutionize how we build and deploy microservices. It enables us to run code written in languages like C or Rust, known for their speed and performance, directly in the browser or on a server. This could mean lightning-fast services with super-efficient resource usage. Whoa! But here's the thing, Diya. As much as I'm excited about these shiny new toys, I truly believe that understanding fundamentals is key to unlocking real performance gains. Technologies may change and evolve, but the principles behind them often remain constant. So my advice: keep honing your skills in core areas like latency reduction, efficient resource usage, and monitoring. They'll serve you well no matter what exciting new trends emerge on the horizon. And with that, Diya, I think we've reached the end of our journey into the heart of microservices performance. It's been an absolute blast chatting with you about this passion of ours. Here's to many more fascinating discussion. Cheers.
What a fantastic conclusion, Mitesh. I'm thrilled we got to explore these exciting trends together. Service mesh, gRPC, and WebAssembly are certainly going to shape the future of microservices. Thank you for sharing your insights, expertise, and enthusiasm with our listeners. It's clear that you're passionate about optimizing microservices performance, and I think we've provided a valuable resource for those looking to improve their own architectures. Before we wrap up, let me just summarize what we covered. The hidden tax of the TCP three-way handshake in microservices. Strategies to mitigate latency. Connection pooling reuse, keep alive, and proxies. Profiling and monitoring workload traffic patterns. Emerging trends, service mesh, gRPC, and WebAssembly. To our listeners, thank you for tuning in. We hope this episode has provided actionable insights and inspiration for your own microservices projects. Don't forget to follow us on social media for more tech talks, interviews, and expert opinions. And finally, a big thank you to Mitesh for joining me today. It's been an absolute pleasure discussing the fascinating world of microservices performance with you. This is Diya, signing off from Tech Talk. Until next time, stay curious, keep learning, and optimize those microservices.